Alright guys, welcome back to the another video. In this video, I'm going to show you how to integrate the ArcGIS API with the open source packages such as Matplotlib or Geopandas to create the beautiful maps, as well as like how to like do the spatial analysis and for example, just for the visualization, how to like visualize those layers in Folium map. So I'm going to show you like how to create this kind of maps. Basically, this is the population change map. So I created using my population USA population dataset. At the end of this tutorial, you will have a clear idea about like how to integrate ArcGIS with open source libraries and then how to do the spatial analysis. So let's get started. Alright, so first step is I just want to show you how my data look like. If I upload this data to the MapShaper, which is the great website for just visualizing data, this is how my data look like as a shapefile, and these are the attribute column, right? And for example, if I click one and I have all the information, and particularly for this particular video I'm going to use the state name, and then I'm going to calculate the population difference between 2000 and 2010 using these columns, and then try to visualize the population change in map. So yeah, that's our objective. So in order to do that, so I created this repo. I'll share this link to this repo in the video description. So basically what we are going to do is we are going to first clone the ArcGIS Python environment and then install the dependencies for this tutorial. So I have dependencies listed here. So we need ArcGIS, Geopandas, Pandas, Matplotlib, Folium, Python.net to store your to store your environment variable, and IPyKernel just to run the Python shell, this Jupyter notebook shell, right? So yeah, so in order to do that, if like installing all the dependency, we can also run the notebook. So in order to run it, so we need to log into the ArcGIS Online, and then we upload the layer to the ArcGIS Online. So basically for this particular video I'm going to show you like how to upload a layer to the ArcGIS Online, and then we'll load that layer, and then we will calculate the percentage change in population, and we create the Cloropleth map using Matplotlib, and also create the Cloropleth map in Folium. So that's our objective of this video. So yeah, so let's get started. So in order to do that, so basically either we can like clone the ArcGIS Python environment, as I showed in my previous video. Maybe it might be above somewhere in the screen, but for this particular video I'm just going to like install all the dependencies using UV library. So in order to do that, so I can open my terminal, and then if you don't already initialize your UV package, you can use pip install UV to install the UV library. For me, I think it's already installed, that's why it says requirement already satisfied. And after that you can get start with UV. And in order to like install the packages with UV, you can write UV add, for example, ArcGIS, and then since I automatically already installed it, so it's not showing anything. But since we already have this pipe project.2ml file, so this is the configuration file. So basically you can use this file. So simply change your directory to the project location where your configuration file is, and after that you can simply write UV sync to synchronize, simply install all the dependencies based on is defined in PyPros 2ML. And if you do this correctly, then you'll see the installed library inside like this lib site package folder, and these are all the dependencies I have for this project. So yeah. All right, so the next step is to like get start and then import the libraries, necessary libraries. For this particular video, I'm going to like import these libraries. These are from ArcGIS, and then this is for Geopandas and Pandas and .env and zip file. And one more thing, so here if you log into your ArcGIS Online portal, then simply you can like create your application basically for other application, and click next, and then add the title, and then it will automatically create it, the authentication app. And then here in the users part, you'll see the maybe in the overview you'll see the client ID, and then simply you need to copy this client ID and then maybe create the .env file and then paste it here. Just replace ArcGIS client ID with your client ID. And after that, so simply we load the all the environment variable, and then this is my client ID, and then this is my folder to the input dataset. So basically it's the USA population dot and then various file format. And then just to log in, so you need this GIS package and then URL to your ArcGIS Online. So basically for me this is simply the URL up to this. And after that you pass your client ID, and if you run it, so it will automatically redirect you to request for permission, and then you can allow it, and you can simply copy this code. This is work is a secret, and then save it. So by default, if you do that, then you are already like logged into the ArcGIS Online portal using your client ID and secret. Instead, you can pass your username and password as well, but I feel like client ID is the good appropriate way to like log in securely. And after that, you can like try to get some content. For example, in my ArcGIS Online, so if I go to content page, there are lots of layers, right? And then you can get whatever layer you want. For example, in case of like river AOI, and if you want to view this layer, simply copy this item ID from this URL, and then you can simply replace this over here. And then if you do that, then you will get that item river AOI, right? And if you click, it will automatically redirect you to the same location. And in ArcGIS Online, so basically there are like item, and then inside item you have several layers, and then inside each layer you will have several features, right? That's how the feature layer are assigned. And then simply in this particular item we have only one layer, which is layer AOI. It can be one or multiple, so simply I have only one layer, that's why I'm selecting the first layer, and then this is my layer. And if you want to see the properties of this layer, so basically like the name and type and other things like for example SRID or the other different kind of like metadata, display field name, description, everything. So everything is available here with the item properties, right? And then in order to get the feature, so maybe I'll disable this. In order to like get the feature from that particular layer, so you need to apply the query function on that layer. And then query will be like in the where clause you can pass 1 equal to 1, or maybe for example name equal to Janakpur, or maybe based on whatever query you want to filter. For now, I want all the features, that's why I'm passing 1 equal to 1, and I want all the field, that's why I'm passing asterisk, and then I want to return geometry as well, that's why I'm passing true. And then there is a nice way to like convert this to the pandas data frame. So if you write features.htf, it will automatically convert it to the pandas data frame, and then using head keyword you can simply show the first 5 results. And then here the one little bit issue with this method is, since it's the Python data frame, not the Geopandas data frame, that's why our shape are written as a path. But of course, if we write it as a Geopandas data frame, then it will automatically correct it, and I'll show you how to get that. And right now, so that's all the like basic idea about like ArcGIS getting layer and then listing it as a pandas data frame. But here I have a code to actually upload my input data set to the ArcGIS Online and then assess it. So in order to do that, so yeah, we are going to upload this data, and in order to upload it, so first of all we need to create the zip file. That's why I write this function, and then simply our zip file will be inside input data USA population.zip, and our input file will be from input data pattern, and input data is from this input data, right? So I defined over here input data part to the input data, right? And yeah, simply we are creating the zip file here, right? Step 1 is to create the zip file, and then step 2 is to upload that zip file to the ArcGIS Online. By default, there is no way to upload it as separate files, that's why I created zip file. And then you can pass the like properties, for example title of the layer, and then tags separated by comma, and then type, and then the description. And after that, simply you need that GIS instance, which is your logged in version of like ArcGIS Online instance, and then content.add to add that item to the ArcGIS Online. And then you can pass the IFTN properties, and then the data is a zip file, right? And then in order to get this, you just need to write GIS content.get method, and simply we upload this as a zip file, and then we need to publish it so that it will publish as a feature layer. And then if we assess it, so it will look like this. So it will take some time to like upload it. So right now you can see my zip file is created successfully, and then now it's trying to upload it to the ArcGIS Online. And if you check it here, so I don't have US population data set right now, but once this process is done, then your data will be available in ArcGIS Online. All right, now we have this layer is a item, and then simply we can click and then check the feature layer. It's already uploaded. And if we check the data section, of course we'll get some information about it, like the state name and all the like attribute table, right? And then yeah, this is our data, right? And then maybe if we like refresh it, we'll get that listed over here. So yeah, these are the data, right? And yeah, the other thing is I want to again like query that layer, and then select the first layer, and then query that again to get it as a like data frame, right? But by default, as I said before, so it will be simply the pandas data frame, not the geopandas data frame, right? That's why we have set as a ring, and then it's not aware of coordinate system. And now we can calculate the population change using pop 2010 and pop 2000 field, which is over here, pop 2000 2010, this is the population data, right? And then population change will be like population change divided by population in 2000 into 100. So this is our population, and if we check our like data frame, then it's like this. So basically we get population change and population change percentage. And yeah, so after that we try to get the like EPSG code of that data. For example, this is the like latest WKID is the EPSG code, which is Mercator coordinate system 3857. So we first, yeah, in order to like convert this above data frame to the actual geo data frame, which is GDF v2, we need to like convert it into the gpd.geodataframe, and then we pass what is the geometry field called its shape, and then what is the CRS, it's EPSG 3857, right? And if we run it, then now we can like scroll and then see the shape like column. Right now it's automatically converted to WKT string. So yeah, which is good. So it's now aware of the coordinate system and the coordinates. But one problem here is like the polygon are in Mercator system, so we might need to convert this to the 4326 coordinate system, which is WGS 1984, in order to visualize it in Folium map. But for now, let's visualize it in Matplotlib. So in order to visualize it, so simply we can use the dot plot function and then pass which column we want to plot it. It's population change percentage, and then our x is legend, and legend keyword is the whatever we want to put it here, and then color map and age color. So basically if I run, I'll get this map. So basically looks like in this state we have lots of change in population, and around this age we have lots of change, but population change in these and few of these eastern state are very less compared to these, right? And this x and y value are the like coordinates of that particular location. So x and y value, easting and northing value. And our population change legend is like from 5% to the 35%. Looks like this state has the more than 35% population change within like these 10 years. All right, so now the step is to like convert that to the GeoJSON data in order to load that into the Folium. So simply I convert that to the 4326 coordinate system, and this geo interface will automatically convert that to the simply like feature collection, right? GeoJSON data, and then I can check the properties. So looks like it's doing perfect, right? And now in order to like add that to the Folium map, so I create the Folium.map with this location and then zoom level, and maybe I can show you how it looks like without like any data first. So for example, this is my map. By default it will be OSM map, and then I'm right now adding the Cloropleth map with my GeoJSON data, and then the data, my actual data will be GDF v2, and then columns I want is state name and population change, and then this is the key one, and then some of the legend visualization properties, and I add that to the map. And in order to like add the tooltip, whenever your mouse is hover over to the map, so we hover over state name and then the population change in percentage, and then we add that tooltip to the Cloropleth map and then visualize it. So if we run this, then we'll see this is the like current statistic. For example, in this particular Nevada state it has like population change of 37%, more than 37%. In Texas we have around 21%, and yeah, and so on. So yeah, and then we have like whole Alaska state is over here. And yeah, this is the cool way to like visualize. And of course, right now your data is in Geopandas data frame. You can do whatever operation you want, like you can integrate this data with the your local data set. For example, your for example, you have some of the like data on hazard or crime pattern, and then you can merge that data based on state and then do some analysis. And you can like use all the spatial operation from like from Geopandas tool. That's also the benefit of like using integrating open source. And the thing is, instead of like using the data set from your organization, you can use the data set from Living Atlas. So basically there are a lot of data in this Living Atlas content. Basically you can search whatever, like for example fire, and then you will see all the layers related to fire, right? And then for example if you click, then you will get this item ID, and then based on that you can simply get this data and then do your spatial analysis using other like open source libraries. For example, you can do the train the machine learning model using scikit-learn library, just based on this data, whatever data you get from ArcGIS Online or Living Atlas. So yeah, this is the cool way of integrating ArcGIS Online with open source. If you want to see more content, for example training machine learning model or with like ArcGIS data or those kind of tutorial, then let me know in the comment section. I'll try to create whatever you want me to do. So yeah, that's all for today. I hope you like it, you enjoy this video. I'll see you in the next.